Hello children. So we saw in our last class, that is chemistry lesson, acid, bases and salts. Okay. So in that we saw the introduction and properties of physical properties of acid, bases and salts. Okay. And then we saw the indicators also, natural indicators and synthetic indicators and olfactory indicators we saw. Okay. So now let us see in this class chemical properties of acids and bases and salts also. Okay, let us see. Okay, so first topic we have acids and bases, the reaction of acids and bases with metals. Okay, acids of, that is the reaction of acids and bases with metals. Okay, the reaction of acids, reaction of acids, okay, reaction of acids with metals, okay, acids and bases with metals. So first let us see about the acids reacts with metals, okay, acids reacts with metals. So acids reacts with metals, it gives salt plus hydrogen gas, salt plus hydrogen gas. See the first thing, acid reacts with metals, okay, acids reacts with metals, it gives, what it does, it gives salt plus hydrogen gas. You know, H2 gas is a hydrogen gas. Okay. So for example, we can take hydrochloric acid here. Okay. Hydrochloric acid. Okay. See, for example, HCl. Hydrochloric acid. Okay. Hydrochloric acid plus metal. Which metal we can take? Zinc. Okay. Let us take zinc here. So hydrochloric acid, that is acid. This acid and metals reacts, acid and metal reacts and gives salt. What is the salt? Zinc chloride. Zinc chloride. What is the molecular formula of zinc chloride? Remember children? Recall it. Okay. Recall it. What is the molecular formula of zinc chloride? ZnCl2. ZnCl2. Okay. See? How to write the molecular formula? The first letter of the formula must be in capital. The second letter must be in small. Don't write both in capital and both in small letters. Okay? The first letter must be in capital. So many of you children did mistakes. What means hydrochloric acid? Write like this. H is capital. And then hydrochloric acid next element is chlorine. No? You are writing like this. This is totally wrong. This is totally wrong. Don't write like this. The C. Okay. If name of the element chlorine, C must be capital and the second letter must be small. Is it right? So C must be capital in HCl also. Okay. Don't write like this. See here. C must be capital. Okay. Little bit bigger. Okay. See. Then sulfuric acid. What is the molecular formula of sulfuric acid? H2SO4. Is it right? Okay. So many of you are writing H2SO4. Wrong. Okay. So this sulfur is also in capital letter and oxygen is also writing in capital letter. Both you write in H2SO4 like this. So all the letters, the first letter must be in capital and the font size also is same. Okay, that you keep in your mind. Then see here, that is HCl, hydrochloric acid plus zinc is a metal. Acid and metal reacts and gives zinc chloride, that is a salt, plus hydrogen gases released. Hydrogen gases liberated. Okay, hydrogen gases liberated. Now you know, see reaction of acids and bases with metals. So first let us see about acids reacts with metals. Acid reacts with metals, it gives salt plus hydrogen gas. This is very important. You should keep it in your mind. Acids, any acids reacts with metals, it gives hydrogen gas. Any acids reacts with metals, it gives hydrogen gas. Hydrogen gas is evolved, and with that the salt should be there. That salt we can say it is a precipitate. That is a precipitate. Okay. Then here zinc granules. Zinc granules is a metal. Zinc granules reacts with hydrochloric acid. It gives zinc chloride plus hydrogen gas. See here, this reaction is balanced or not. In any reaction we can write that reaction must be balanced. Is it right now? You know that. Okay. So in chemical reactions and equations, in that only we know. Okay. If anywhere we can write the equation, we have to write the equation with balance. Okay. See here, hydrogen is only one hydrogen molecule in LHS side. In reactant side, only one molecule. So in product side, we have two molecules. Okay. So here chlorine is also only one molecule. In product side, we have two molecules of chlorine. Is it right, children? Okay. So here we can write two. Okay. Here now see, hydrogen is also having two molecules in reactant side, and chlorine is also having two molecules in reactant side. Now it is balanced. No, see, check it once. Hydrogen two molecules. Here also two molecules. Here chlorine is also two, and zinc is one. Here zinc is one. Chlorine is two. Okay. Now it is balanced. Okay. Now we will move on to the another one. Bases reacts with metal. So bases reacts with metal. So bases also reacts with metal to evolve hydrogen gas. Bases also reacts with metal. Bases also reacts with metals to evolve hydrogen gas, and it gives also salt. Okay. See, base reacts with metals. It gives salt plus hydrogen gases evolved. Okay, hydrogen gases evolved. Okay, so acid and base both reacts with metals. This is very easy now to keep in your mind. Acids and bases both reacts with metals, and it gives salt plus hydrogen gases evolved. Hydrogen gases liberated. Okay, so for example, here. So what is the base we can take? What is the base we can take? That is sodium hydroxide. Okay, sodium hydroxide. NaOH. See, NaOH. A must be small and another letter is like sodium in sodium. The symbol Na in the first letter. N must be capital, and O oxygen is capital, and H hydrogen is also capital. Sodium hydroxide plus metal. Here we can take the metal zinc. Here also we can take the metal zinc. So sodium hydroxide reacts with metal zinc. Okay, it gives sodium zincate. Okay, so Na to ZnO2. Okay, Na to ZnO2 plus hydrogen gases evolved. Okay, see here, sodium hydroxide reacts with zinc metal. It gives sodium zincate. Okay, what's the name of this? Na2 ZnO2. Sodium zincate is a salt. Sodium zincate. Okay, sodium zincate is a salt. Sodium zincate plus hydrogen gases evolved. Okay, see here, that is here also the equation we want to balance here. Okay, see sodium only one atom here. Here two atoms of sodium. Okay, so here oxygen 1, here oxygen 2, and here hydrogen 1, here also hydrogen 2. Okay, so we want to multiply here by 2. Okay, so now let us see the equation is balanced. Okay, see here, you keep it in your mind. The first reaction of acids and bases reacts with metal. Reaction of acids and bases with metals. So acids reacts with metals. It gives salt plus hydrogen gas. It gives salt plus hydrogen gas. So hydrochloric acid plus zinc. Zinc is a metal, hydrochloric acid is acid. So acid plus metal, it both reacts and gives zinc chloride. Okay, this is a zinc chloride, is a salt plus hydrogen gases evolved. Okay, and then base plus metals reacts and gives salt plus hydrogen gas. So both acids and bases reacts with metals, it gives salt plus hydrogen gas. Okay, so give one example for this. Are you listen clearly, carefully means don't read, it is not necessary. When you are hearing, this is keep it in your mind. Okay, so the first reaction of acids and bases with metals, it gives salt plus hydrogen gas. Salt plus hydrogen gas. Okay, so sodium hydroxide is a base plus metal is zinc, it gives sodium zincate. It is a salt plus hydrogen gases evolved. Okay, so here all the acids reacts with metals, it gives salt plus hydrogen gases evolved, but most of the bases doesn't react with metals. Okay, so why? Because in that bases also having a metal. Okay, so that metals doesn't react with the metals. Okay, so form a salt. Okay, so that is metal must be more reactive than the metals that is present in the bases. So for this reaction doesn't take place. Okay, so the metals which is present in the base. Okay, so this is not more reactive than metal present in the base is that reaction doesn't place. Okay, doesn't take place. So here sodium and zinc we took. So zinc is more reactive than the sodium. Zinc is more reactive than the sodium. So we can that is this reaction takes place and gives salt plus hydrogen gas. But here we have take less reactive metal than the sodium means there is no reaction takes place. Understood, children? Okay. So all the acids reacts with metals. All the acids reacts with metals. It gives salt plus hydrogen gases evolved. Okay. But some metals present in bases. Okay. So here we take less reactive than the metal which is present in base. That reaction doesn't take place. We are taking the metals which is more reactive than the metals which is present in the base. That reaction takes place and gives salt plus hydrogen gases evolved. Okay, understood, children? The first reaction of acids and bases with metals. Okay, so acids and bases both reacts with metals, it gives salt plus water. But all the acids are reacts with metals, it gives salt plus hydrogen gas. Salt plus hydrogen gas. But some metals which is less reactive than the metal present in base, so that reaction doesn't take place. Okay, so the metals which we are taken that is more reactive than the metal which is present in base only, that reaction takes place and gives salt plus hydrogen gas. Understood, children? Okay, then we move on to the another topic, reaction of acids with metal carbonates and metal hydrogen carbonates. Okay, metal carbonates and metal hydrogen carbonates. Reaction of acids with metal carbonates and metal hydrogen carbonates. Metal carbonates and metal hydrogen carbonates. Okay, so here we are taking only the acids. Okay, so acids reacts with metal carbonates and metal hydrogen carbonates. So acids reacts with metal carbonates and metal hydrogen carbonates. to form salt, carbon dioxide and water. To form salt, carbon dioxide and water. See, that is acid. First we can take metal carbonates or metal hydrogen carbonates. See, metal carbonates or metal hydrogen carbonates. Any compound we can take. Okay, metal hydrogen carbonates. Any carbonate we can take. No? So we can take, for example, metal carbonates or metal hydrogen carbonates. So both we can take means it both reacts with acids. Both reacts with acids. It gives, what gives? What it gives? Carbon dioxide. Okay. So that is salt plus carbon dioxide plus water. So metal salt plus carbon dioxide plus water. Okay, metal salt plus carbon dioxide plus water. Okay, so let us see one example. We can take that is acid, hydrochloric acid plus metal carbonate. One example for metal carbonate and one example for metal hydrogen carbonate. What is metal carbonate? That is sodium carbonate. First example is sodium carbonate, Na2CO3. Okay, plus acid. We can take hydrochloric acid. So the hydrochloric acid means, so metal carbonate reacts with hydrochloric acid, it gives salt. Okay, so what is the salt here? Sodium chloride. Sodium chloride. NaCl. Okay, so you can know the formation, what it forms. Okay, that you know means you can write the equation very easily. See, metal carbonates reacts with acid, it gives salt plus carbon dioxide plus water. Salt plus carbon dioxide plus water. See, metal carbonate is sodium carbonate. What is the molecular formula of sodium carbonate? Na2CO3. Na2CO3 plus HCl, hydrochloric acid plus HCl, hydrochloric acid. So metal carbonate plus acid, it gives salt. Sodium chloride plus, what is given? This is, you know, sodium, carbon dioxide plus water, H2O. Okay, after writing this equation, you should balance it. Okay, you should balance it. So sodium is 2 molecules here, here only 1 molecule. So here another one, chlorine, see here only 1, here also 1. So we can write 2 here. Okay, then we can write 2 here. Okay, so now here hydrogen 1, here hydrogen 2. So now it is balanced. Then oxygen, see, oxygen 3, oxygen here. See here, 2 plus 1, 3, and carbon 1. Now it is balanced. So first you should write the equation, then you should balance it. Okay, so for that you should know the correct molecular formulas of the compounds. Okay, then sodium carbonate plus hydrochloric acid, that is metal carbonate, reacts with acid, it gives salt plus carbon dioxide plus water. Salt plus carbon dioxide plus water. See here, metal carbonates or metal hydrogen carbonates reacts with acids, it gives salt plus carbon dioxide plus water. Okay, now let us move on to the another one, metal hydrogen carbonate. What is metal hydrogen carbonate? What is metal hydrogen carbonate? NaHCO3. You know, okay? What NaHCO3? NaHCO3. Metal hydrogen carbonate. Sodium hydrogen carbonate reacts with hydrochloric acid. Okay, so reacts with hydrochloric acid. It also gives the same thing, that is salt plus carbon dioxide plus water. Okay, now see this also balanced or not. Now this also balanced or not. See here how to balance. See here Okay, so then you move on to the another set of equations. So what is another set here? You know, that is metal carbonates and metal hydrogen carbonates reacts with acid. It gives salt plus carbon dioxide plus water. Okay, so here carbon dioxide can be tested. How carbon dioxide is evolved? How to test? Carbon dioxide is tested while using the test tube, and this is passing it through the lime water. Okay, this carbon dioxide, which is evolved, in the reaction. The reaction takes place. Carbon dioxide is evolved, and salt is precipitate. Okay, and water is in the aqueous form. It is in the liquid form. Okay, when carbon dioxide is evolved, we can see the precipitate sodium chloride. Okay, that is salt. And water also, it is in the liquid form. We can able to test. And how to know carbon dioxide is evolved? Okay, how to know the carbon dioxide is evolved in this process? So by this, we can test by the test tube. That is, we are passing through this carbon dioxide through the lime water. What is lime water here? What is lime water? What is lime water here in chemistry? So not a lemon water. Okay, not a lemon water. You know about quicklime, no? You know about quicklime. What is quicklime? What is slaked lime and what is quicklime? Recall. We saw in our last lesson. That is chemical reactions and equations. In that only we saw. What is quicklime? What is quicklime? Calcium hydroxide is a quicklime. Can you remember, children? See, calcium hydroxide is a quicklime. CaOH2. The molecular formula of calcium hydroxide is CaOH2. Okay, so we are passing through the carbon dioxide through this quicklime. Okay, we are adding carbon dioxide. This gas is evolving now that we are connecting to this calcium hydroxide. Okay, so these two reacts and gives calcium carbonate. So this forms a milky. This forms a milky. Okay, calcium carbonate plus water. Calcium carbonate plus water. Okay, so if we are passing through, the excess of carbon dioxide is passed through the lime water. The excess of carbon dioxide is passed through the lime water. It gives calcium carbonate. After passing carbon dioxide, it changes into calcium carbonate. No, it changes into calcium carbonate. While it passes through the calcium carbonate, again we are passing. Okay, plus carbon dioxide, the excess carbon dioxide. Okay, that forms what is the form? Okay, it is a solution. Milkiness disappears. The milkiness disappears. It disappears totally. Okay, it forms calcium hydrogen carbonate. Okay, so here in this form, milkiness disappears. Milkiness disappears. Okay, so here these are the reactions. Okay, explain acids reacts with metals carbonates or metal hydrogen carbonates. Okay, so what we form? Okay, that is the question should be asked. Okay, explain reaction of acids with metal carbonates and metal hydrogen carbonates means you should explain this much of explanation. Okay, so first you should write the general formula. Metal carbonates or metal hydrogen carbonates reacts with acid. It gives salt plus carbon dioxide plus water. Salt plus carbon dioxide plus water. So metal carbonates and metal hydrogen carbonates reacts with acid. It gives salt plus carbon dioxide plus water. So metal carbonate we can take Na2CO3. Sodium carbonate is an example. Sodium carbonate plus hydrochloric acid. So sodium carbonate is a metal carbonate reacts with acid hydrochloric acid. It gives sodium chloride is a salt plus carbon dioxide plus water. Carbon dioxide plus water. Next, metal hydrogen carbonate NaHCO3 plus hydrochloric acid. It gives NaCl plus CO2 plus H2O. Then calcium hydroxide. Okay, so calcium hydroxide reacts dioxide gases evolves. How to test that? We are passing through this carbon dioxide gas through the quicklime. So what is quicklime here? Calcium hydroxide. So we are passing through the carbon dioxide gas through the quicklime. It turns into milky. What is the milky? Here calcium carbonate, and with that water also forms. Okay. So this calcium carbonate, while this we are passing through the carbon dioxide, excess carbon dioxide, that is the milkiness disappears. The milkiness disappears means here calcium hydrogen carbonate. Okay, calcium hydrogen carbonate. The molecular formulas is very important here. Okay, so now you understood, children. Are you clear here in this concept? Reaction of acids, okay, with metal carbonates and metal hydrogen carbonates. Okay, so bases do not react with metal carbonates and metal hydrogen carbonates. Okay, so reaction of acids and bases with metals. Okay, with metals, that is both reacts with metals, it gives salt plus hydrogen gases evolves. Okay, that you keep in your mind. But here in metal carbonates and metal hydrogen carbonates, metals and carbonates, acids only react with the metal carbonates and metal hydrogen carbonates. It gives salt plus carbon dioxide plus water. Okay, salt plus carbon dioxide plus water. But bases doesn't react with metal carbonates and metal hydrogen carbonates. Bases doesn't react. Okay, so bases doesn't react with metal carbonates and non-metal carbonates. Metal hydrogen carbonates. If they are asking any question about that, you should write bases do not react